Designing a sales forecasting AI model involves several steps, from data collection and pre-processing to model selection and evaluation. Here's a step-by-step guide to help you design an effective sales forecasting AI model. Pradeep K. Suri, author and researcher. 1. Define the problem. Clearly define the sales forecasting problem you want to address. Specify the scope, such as the time frame, example monthly, quarterly, yearly, product categories, and geographical regions. 2. Data collection. Gather historical sales data. This data should include relevant features such as sales figures, product attributes, marketing spend, seasonality indicators, economic indicators, and any other factors that might influence sales. 3. Data pre-processing. Clean and pre-process the data. This may involve handling missing values, outlier detection and treatment, and encoding categorical variables. Ensure the data is in a format suitable for machine learning. 4. Feature engineering. Create meaningful features from the raw data that can help the model capture patterns and relationships. For example, you can create lag features to account for time dependencies and rolling statistics to capture trends. 5. Data splitting. Split the data into training, validation, and test sets. The training set is used to train the model, the validation set helps tune hyperparameters, and the test set is for final evaluation. 6. Model selection. Choose an appropriate machine learning or deep learning model for sales forecasting. Common choices include time series models, example ARIMA, exponential smoothing, regression models, example linear regression, decision trees, and neural networks, example LSTM, GRU. 7. Model training. Train the selected model using the training data. Ensure you use appropriate evaluation metrics for regression tasks, such as mean absolute error, MAE, mean squared error, MSE, root mean squared error, RMSE, and R squared, R superscript 2. 8. Hyperparameter tuning. Fine-tune the model's hyperparameters using the validation set. This may involve adjusting learning rates, batch sizes, and network architecture, if using deep learning. 9. Model evaluation. Evaluate the model's performance on the test set to assess its ability to make accurate sales forecasts. Compare the model's predictions to actual sales figures using the chosen evaluation metrics. 10. Model interpretation. If applicable, analyze the model to understand how it makes sales forecasts. Some models, like decision trees and linear regression, offer interpretability, which can provide insights into the factors driving sales. 11. Deployment. Once you are satisfied with the model's performance, deploy it in a production environment. Ensure it can handle real-time or batch predictions, depending on your needs. 12. Monitoring and maintenance. Continuously monitor the model's performance in the production environment. Retrain the model periodically with new data to keep it up to date and accurate. 13. Post-deployment analysis. Analyze the model's predictions in a real-world setting. Compare the forecasts to actual sales and gather feedback from stakeholders to identify areas for improvement. 14. Scalability and optimization. If your sales forecasting AI model needs to handle a growing volume of data or an expanding product portfolio, consider optimizing its scalability and efficiency. 15. Consider external factors. Be aware of external factors that can influence sales, such as market trends, economic conditions, and competitive factors. Consider incorporating external data sources into your model for better accuracy. 16. Documentation. Document the entire process, including data sources, pre-processing steps, model architecture, and hyperparameters. This documentation is valuable for future reference and model maintenance. Remember that sales forecasting is an iterative process, and model performance can improve over time with feedback and data updates. It's essential to involve domain experts, data scientists, and business stakeholders in the design and deployment of your sales forecasting AI model to ensure its effectiveness in meeting your business objectives. Thank you.